Alright, so hi, I am Arya and this is going to be a talk on Geosteered load balancing on a budget. So this is just going to be a talk on the basics of how I geosteered this infrastructure I had for a hobbyist project of mine called Project Sigford. So yeah, before I begin explaining what I did and all, this is going to be a bit about me. So I'm just a free software user and I just happen to be a hobbyist sysadmin. I'm also a student and the project I'm going to talk about here is called Project Sigford. So basically what it is just a few friends online who have a few VPSs and physical server. So what we do is we just host mainly two things, privacy frontends and Pubnix. So Pubnix is a pretty old concept, so it dates back to SDF in the 90s. So a Pubnix, basically what it does is that, so once you sign up, you get a Linux shell where you can host websites and all that. But that's not going to be the main topic about this. So other thing is the privacy front end. So basically, when you access YouTube, Twitter, all that, it is a privacy invasive service by design. It is proprietary and all that. So what a privacy front end does is that it will make sure that it'll scrape the data from the privacy invasive website and then put it in a better UI which has no ads, no tracking and all that. So yeah, and if you want more information about the project, you can find it over at psf.lt. And we also host a few other services like HDoc, which is for markdown notes and all. But yeah. So then coming to the main part of the talk, which is going to be geosteered load balancing. To explain what the geosteered load balancing is, you first need to know what load balancing is, and this is a pretty simple concept. So instead of having all the so say we have 1,000 requests a second, instead of having all the 1,000 requests going to the server at one time, so this 1,000 requests will overload the server because the server is generally not that powerful. So instead you divide it into multiple smaller servers, so each server has less load and hence can perform faster. So this is done using a front-facing web server or a DNS server, which will balance the request to multiple servers based on the amount of load or other factors. So yeah, in the case of geosteered load balancing now, what the geosteered load balancing does is, instead of balancing it based on the amount of requests or the power of the server, it instead balances it based on the location of the user. So suppose you are accessing this website from US, it'll redirect to the node closest to your location. Same for EU, same for IN and all that. So that's the main part of geosteered load balancing. So yes. So why would you want to load balance in the first place? I already mentioned most of this in the previous slide, but you get better performance, faster load times, and another important thing is that one server going down will not result in your entire infrastructure going down, because it's a load balance and you can just fail over to another server. And it's also a great motivation to automate your infrastructure, because you cannot just apt install on every single server 10 times. So yeah, and it's also a great way to learn things, of course. So yeah, now comes the main part about why would you geosteer load balancing instead of just doing normal round robin or something like that. So this is because this provides better performance because it's a server closer to them, and also it's the more important regions can be upgraded separately. So in the case of a normal round robin setup, like a basic round robin, what happens is that each server gets an equal amount of requests, but then this means that you can't suppose you have a lot of users from the EU, but you still want to give a good experience for people in the US or India. So then you have to still have the server, still have servers in US and India, but then you don't need to have such a powerful server. So in this case, we can upgrade the EU separately while having the EU, US and IN servers still the same lower specs. This is what Geosteered load balancing gives us. So from what I have seen, most corporates and stuff, what they do is that they have a Geosteered along with round robin. So for one region, they would have like a round robin, I guess you could say. So if you geosteer to one region, and then from there you can round robin between the servers in that region. So and this thing is that why wouldn't you use something like Cloudflare for load balancing? Why do you want to self-host it? Why do you want to do this jugaad, which is going to eventually fail anyways? And for this, it's basically just we are poor and we don't want to MITM the entire things, because when you do something like Cloudflare, every single request has to go through them, and technically they will still be able to decode everything. So, and when you're hosting such stuff called privacy frontends, you wouldn't want an MITM between all of your requests. So, yeah. And then now, why would you should you put the load balancer on your web server or on your DNS server? So we do DNS based load balancing. This is what most Geosteered people do, because in geosteering you don't need much of the extra features, and also the latency is the main goal here. So the web server also result in more latency, because by design a web server, when you go to web server you have a lot more latency, and it has the web server isn't also load balanced. So there's one web server in one region. So and then from that redirected, that'll add a lot of latency, and also caching isn't that easy. But then again, there's also resiliency. The argument that DNS is more resilient compared to HTTP. And other than that, we also we do have to mention the TLS stuff. That is, I had a slide about TLS, but it's just too complex and pretty simple. So at the same time, so that's one thing. And so we miss a lot of features like that. And also health checks is not going to be easily doable with a DNS based load balancer, because a DNS based load balancer is pretty much a dumb load balancer compared to a HTTP one, which can actually do a lot of extra features. At least the one I use. Maybe Power DNS or something can do extra stuff, but I'm not really sure about that. So this another thing, health check. So if one server goes down, then it will be automatically loaded to another server. This feature is not available generally with a Geosteered load balancer. A DNS based load balancer, because the DNS is, again, as I said, it's a dumb load balancer. And yeah. Okay. Yeah. So now I'll come to the overview of infrastructure. So this is going to be a basic of how it works. So right now we first get a request from the user. So then the user's DNS resolver will of course take it to the user's DNS resolver will go to the authoritative DNS resolver. There's this big way of how it works from the user to caching to authoritative and all that, but it doesn't matter. So the only thing that matters is that user's DNS resolver send a request to the authoritative DNS resolver. Has hosted its masters in our EU server. We don't have a separate DNS server, DNS server, because cost again. And then we have a slave in the US server. And so once the request comes, if the domain is a Geosteered domain, we have configuration for that. I'll show it later. If it's a Geosteered domain, then it is passed to the NOT module GeoIP. NOT is the DNS server we use, and the GeoIP module, what it does is it takes the IP used from eDNS client subnet. So this is a header basically that the DNS server gives, and using this header, what you can do is that the DNS server will forward the IP of the user who made the request. So with that IP information, it will get the approximate geographic location of the user by using maxmind GeoIP late, right? So they have two options for this. As maxmind ka paid version, which actually gives basically accuracy up till the city. Then also the free version which we use, again because we don't have the money to do that. So this will basically give up to the state, you could say, like the state inside the country, which is good enough for us. And then using that, it will return that the correct IP back to the DNS server, and that IP will be and then this the correct IP that has been returned to the DNS server by the user. This IP will then be used to connect to the exact node. So we have 3 nodes right now, which is one in the US, one in Germany, and one in India. So the one is in US is hosted on TrackNerd, the one in Germany is hosted in Avoro, and the one in India is just hosted in an old laptop that doesn't even have a working fan. So then we have our DNS setup. This is the most complicated part of the infrastructure basically. So we use NotDNS. It is made by the maintainers of the .cz domain extension and the TLD rather. So it works with standard zone files, and it was easy to set up. That's the only reason we went with it. There is not like any real reason for it. So we have as I said before, our DNS runs on the normal servers. We don't have anything special for it, and we just keep it in sync using IXFR. So it's the standard DNS protocol for keeping things in sync. Then for SSL, for the SSL we use DNS authentication, right, for Let's Encrypt. So for this we use RC2136, which is a dynamic DNS updates. Again, this uses HMAC, and it's again synced using IXFR. Then we have NOT module GeoIP, which is a GeoDNS, as I mentioned before. It is kept in sync between the master and slave using a hacky bash script, because IXFR doesn't work with that. Again, that's got to be a lot of hacks in this. That's why it's called jugaad. So. this is the kitty terminal, by the way. Right. So this is an example of the GeoDNS in action. So I'm in 3 servers right now. One is my laptop in India, one is in the EU, and one is in the US. So if you see here, I made a dig for lr.psf.lt so from India. So that will give me the CNAME for in.psf.lt. Then, right. So here you can see that it will give the result for in.psf.lt. If you do it from India, then again same for US, it will give the pizza one, which is a EU node. Then if you go to the next one, then for US it will give the same thing, us.psf.lt. That's basically how it works. Okay, then, so the GeoDNS is going to be pretty simple. So what we do is we have a wildcard for, this is basically generated using a hacky bash script. So we have a list of domains and a list of boilerplate, and it just a bash script just combines it and then syncs it between the servers. So for Asia, Oceania, for Asia alone we have India, the Indian node, so we just rename it to that. Then for basically everything else like US, the South America, North America and Australia, we have usually CNAME to US node, and again for the EU we have EU in Africa, we have EU node. And then of course if the GeoLite 2 database fails, we have failover to always go to the EU node. So this is basically our script to sync it. So it just takes the remote, then it just merges all the SSH files from the domains and the template, and then it just copies it to the other server using SCP and restarts node. That's it. So that's what I meant by jugaad. And, Alright, so now I'll come to Ansible. So what we do is we use Docker for most of our services, right? So this means that we can easily keep it in sync. There is no like, so I don't have the pain of having to apt install on every single server. I mean, we still have to do that, but it's not to that extent. And so then to manage our compose stacks and set the sysctls, manage backups, manage tailscale, for all that we use an Ansible file. And to set up our Docker stacks, we use this Ansible root I made myself. So this basically allows us to declaratively write the compose files each in a variables file, and then once we run the Ansible, it will deploy it to its own Docker composes. So then we have our so this is a weird thing we did. So instead of having all the setup in one file, we divided into multiple playbooks, which is playbooks, and Ansible is basically just a list of instructions. So yeah, you can find the Docker compose role in cadb.in/docker-role, and the Git repo on cadbin/psf.ansible. Yeah. If it doesn't work, blame Amog. And so this is the playbooks what we use. So we have the one thing called node-specific playbooks. These just set up things that are specific to the server themselves. So like for example, Tor, VPN. That's our internal VPN. Then our email service. That's all only running on one node. So for that we use a node-specific playbook with Ansible. Then for all our other servers, we use this thing. This applies the basic setup. So it sets up the users, shell configuration, SSH config, all the repos, packages, sysctls, and a firewall, all of that. We also use a custom, not ours, but I can use another tailscale role in order to get all the hosts onto the tailscale network and also automatically configure backups. But then again, in the backups case, we do not actually put the passwords there for obvious reasons. Instead, we add it as a special file. Yeah. And then lastly, we have proof frontends. That is going to be our main focus. So this basically syncs all the Docker stuff and the web server. So we use Caddy for the web server. This basically means that this basically means I can just put everything in one file pretty easily, and the configuration can be easily Ansibleized. So I just use templates and this Ansible role to install the Caddy server itself. This is all handled by the proof frontend playbook. We also have fail to man, which is for bots. Again, this is again a custom configuration we had to use because no one really supports Caddy with all the ancient pieces of software. But yeah, so again I have to show. So this is what I was talking about when I said declarative. So you can see here under apps we have a hyperpipe, which is a privacy funded for YouTube, YouTube Music rather. So instead of having to declare the compose file for each site and then add it to each server, instead we use this, which will basically declaratively declare it as an Ansible role. So you can see the Docker settings, and under that we have services, the name of each container. So it will basically allow us to declaratively do everything. And for configs as well, we have this thing, we have this way to this jugaad to copy over the configs to every server. We use again Jinja 2 templates for that. But yeah, that should be it. Yeah, and again for the things like for secret keys, HMAC keys, and all, we use Ansible Vault to hide that. Else I also talk about the other thing we use called semaphore, where it's all stored. So that should be it. Yeah. So now to deploy the playbooks, what we do is we do not actually run it from our system, because when you don't do it from the system, you also have the risk of adding system-specific dependencies. You also have to have the credential for every server, and because we use a custom Ansible user, we don't want every team member to have access to the user. So what we actually did is we just created a SSH key, and then we just put it on the server and remove it from our system. So this means we have to use a semaphore to do all deploying, all the deploys. So semaphore is basically web UI for Ansible. It also allows you to do cron jobs and such, and it makes sure that we don't have to have, as I mentioned before. So we also have, instead of doing cron jobs and all, what we do is we actually put it on Ansible itself, because Ansible, because if you have to put the cron job on each server, that'll again be painful, because when you want to modify it, you have to go to every single server. That's not fun. And using semaphore, all the secrets like in the vault decryption keys and all, they're all encrypted. So even if someone has access, they will not be able to use it. But yeah, that should be it, semaphore. Just so this is the semaphore UI. If you see here, if my mouse would work, that is, hyperred always fails in the worst times. So here I can have all the task templates. So all is our main playbook. Then I have caddy builds on Pubnix, caddy builds on Solid. That's one of our old servers. It should not work right now, but I'm not sure how it's working. Then caddy conf update. So if I go to cron, so this is the main part here. So what it does is, so see, this is for updating the caddy. So this uses the caddy role to check for updates and make sure it works. And yeah, so the template basically allows me to specify if it loads, that is. Yeah. So it basically allows me to specify how often the cron should run and such. And it also lets me add the secrets. So this is our global secrets file, which I had to add like this because, again, jugaad. And you also have the manually run things. This is a pretty simple UI. It doesn't have much in terms of features and such, but yeah, this should be it. And finally, Tailscale. Yeah. So Tailscale is a basically like an internal network of such. So if you know WireGuard, the VPN service, it basically uses that to make all the internal networks. So make all your systems be on one internal network, so you can access it without having to. So you can access all the systems together without having to expose the SSH and other things to the public network. So that's why we use Tailscale for this, and it also prevents us from wasting storage by having millions of auth.log lines. And yeah, so all our administrative UIs and our SSH are restricted to Tailscale. And as mentioned before, Tailscale is auto provisioned. So we have a Tailscale auth key, that is a permanent auth key, which is which the Tailscale role uses to auto provision all our nodes to use, and we have all our computers and nodes connected to this, so it will actually work properly. But yeah, that's it. If you have any questions, you can ask it, and if you have any questions, you can ask this, and otherwise I have my contact and website. Yeah.